Now that we are familiar with integrals, we can calculate average values of functions. So at the end of this lesson, you'll be able to find the average value of a function over an interval. Okay, so let's look at the definition of the average value of a function on an interval first. If f is integrable, which means you can take the integral on the closed interval from a to b, that would mean that it's not discontinuous between the endpoints between a and b, then the average value of f on the interval is 1 over b minus a times the integral from a to b of f of x. So basically what this is doing is actually finding the area under the curve, and then we're multiplying by 1 over b minus a. We're pretty much dividing by how many units there are in between. So we really are just taking an average. This is just our fancy way of taking that average. So when we do a problem like this, I will allow you to use your calculator. However, we'll have to always make sure we put the 1 over b minus a outside of that integral when we do the problems. Okay, so let's go ahead and take a look at some examples. It says to find the average value of the function over the interval, and this is f of x equals x squared plus 1 over x squared from 1/2 to 2. So the first thing that we want to do is just set up our problem. So if it asks me for an average value, it's going to be 1 over b minus a. The first value will be the a, and the second value will be the b. So it's going to be 1 over 2 minus 1/2. And I'm going to simplify that a little bit just because that's kind of tedious to put in my calculator. When I calculate 2 minus 1/2, this would be 4 halves minus 1/2, so that would be 1 over 3 halves. And then if I multiply it by the reciprocal, it's going to be 2/3. So 2/3 is going to be on the outside, and then we're going to go from 1/2 to 2. It's always from the smaller number to the larger number, and then just of the function. So we can just put f of x dx, and it is the independent variable is x. So we do want to make sure that we do make a notation of that. So from here now, we can let our calculator do all of the work. So what I did is just put x squared plus 1 over x squared in as y1 in my calculator, and then I could use the math 9 feature. One thing that I'd suggest that you do is put the 2/3 in before you hit the math 9 so that you don't forget to multiply by 2/3 when you are done. So after you do that, you should simply get an answer of 2. So that would be the average value of this function. So the average y value from 1/2 to 2 is 2. Okay, number 4, it says the function v of t equals 40 over t minus 5 squared models a runner's velocity during the first 4 seconds of a race. Determine the average velocity of the runner during these 4 seconds. So as soon as the second we see the word average, we know that we're going to use the formula 1 over b minus a times the integral. So we're going to have 1 over b minus a. In this case, we're running for the first 4 seconds, so it's going to be from 0 to 4. So it'll be 1 over 4 minus 0, which will just be 1/4. My integral will go from 0 to 4. And then what did it say to find the average of? It said to find the average of the velocity. Well, they gave us a velocity formula, which is just v of t. And in this case, since t is the independent variable, we are going to put dt. And then from here, we can simply, just like we did on all the other problems, just put v of t in for our y1. In our equation, we will have to use x, of course. And then again, don't forget that we do want to multiply by the 1/4. So again, I'd suggest putting the 1/4 in your calculator before you hit math 9. And when you do that, you should end up getting 8. And since it was a velocity, we do want to have a label. It didn't tell us whether it was meters or second or feet, so I'm just going to put units. But a velocity is like how fast something's going, so it will be units per second. So that's what we would do on that one. Okay, problem number 5 says to find the average value of the function on the interval, sorry about that. Okay, and notice they did give us an interval. We've just got a piecewise function going on, and notice they did give us a piecewise function, and they also gave us a picture. So I will show doing both of those how we would do this. So the first thing that we want to do, if I'm finding an average, the biggest thing is we want to do 1 over b minus a. So that will end up being 1/6. Okay, now this one's going to be a little bit different because we do want to find the integral from -4 to 2, but we can't because it's split into 2 parts. So we're actually going to take the integral of each part and add them together. So the first one I'm going to take the integral is -1 to -4. We have to do the smaller one first. So -4 to -1 of x plus 4 dx, plus we will add it to the integral from -1 to 2 of -x plus 2 dx. Okay, so that's the setup that we are going to have. Notice that I didn't try to split the 1/6, we do want to always, if the interval goes from -4 to 2, that's what we're going to do the 1 over b minus a of, and then we can add to get those intervals. So now from here, we can go ahead and figure this all out on our calculator. When I put it in, just a little heads up on this, I put this function in as y1 and this function in as y2. So then when I calculated, I could still put it in all as one answer, but you can choose how you would like to put that in. When you do that, you should get a final answer of 1.5. All right, I wanted to show you how we could get that same answer if they do give us a picture of that same setup. So this is the function, the piecewise function. This is the picture of what the piecewise function looks like. And if they ask me to find an average value from -4 to 2, we still want to do the 1/6 on the outside. But when I'm looking for the integral, I'm really just looking for the area under the curve from -4 to 2. So notice we could just find the area under this curve from -4 to 2. And notice it's a triangle, so I could do 1/2 times the base. The base of that triangle is 6. And then the height of that triangle is 3. So it's going to be 1/6 times 1/2 times 6 times 3 is 9, and then 1/6 times 9 is 1.5. So either way you do that, you'll get the same answer. A lot of times they don't give us a picture, so then we can just make sure that we set it up into 2 integrals. So that's how you do it. So hopefully now you are familiar with how to find the average value of a function over a given interval.